Hello guys, and welcome back to another video. In this video I will show you how to make a very fast and efficient piston engine in scrap mechanic. In my last video I showed you how to make a V8 that makes 200 horsepower and 7,000 Newton meters of torque. However, it only makes 300 RPM because 300 RPM is usually the limit for conventional engines. Well, lucky for you guys, because I know a piston engine that makes crazy power and makes crazy RPM. And no, it is not an inline 4 nor a V8, but instead it is what you call a KIN engine. This is just a regular stroke, a regular stroke, a stroke that the most conventional engines use. And it is also a really solid crank. So yeah, let's try to activate this. And as you can see, it is really good and it's crazy fast as well. So if you measure it, it makes about 600 RPM. Alright, 600 RPM if you guys can see on the moving average. Well, obviously not on the highest values, but it is crazy. So this one also uses 8 piston, but do keep in mind that this engine is really allergic to logic gates, because I definitely know well that some people here that will end up making this piston engine with logic gates. Well, my friend, please stop using logic gates, I am telling you. So yeah, this is the piston engine, and I mean, this is just the tip of the iceberg, because I know some other designs like the variable stroke designs, which I'm going to show you right now. Now, this is the 8 piston short stroke engine. I mean, just like the other one, this one also uses the 8 piston engine layouts, but this one is a little different. It doesn't have both sides anymore. It's only one side, and it's now a variable stroke, so which means this thing can go 1200 RPM or even more. And as you guys can see, it makes 1200 RPM. So if you're wondering how well this thing performs in a dyno, I'm going to show you right now. So this one is only 700 RPM, but it's the same 8 piston engine. This one is just only 700 RPM, with just about 100 RPM more than the last one. So yeah, it's also the same variable stroke design, except that it looks a little different. It uses the zero width block technology. So yeah, let's just activate this bad boy. And also let's just for some reason this type of engine is pretty much allergic to lag, so I guess yeah, you shouldn't make this type of engines when you have a really terrible PC. But as long as you have over 60 FPS, maybe you're good. So now let's measure it, or dyno, my bad. Alright, so let's see what this thing can offer. I mean, this engine here is made by me, so yeah. So it makes about a crazy 285 horsepower without a tremel gear at all, and it only uses 8 pistons, and it is not stack, because I've heard that some people just make their V8 stack in one cylinder and to make it have 400 horsepower, but that's just, of course, just pretty much crazy. But this thing, it's not even stack, it's just pure 8 pistons, and it makes 285 horsepower. And the highest horsepower you can make with this thing is pretty much 300 and above, because this one, yeah, it's decent, but it works, because in fact I have it on some of my vehicles. So yeah, I'm gonna show you how to make one just about right now. Alright, so let's start by making a pass-through. I'm sure you guys already know how to make one. So I'm using the Better Lift mod to make that happen. So let's put the 90-degree offset sensors Instead of any other blocks, I really recommend to use mesh blocks because it uses less collisions. So yeah, so as usual, 4 block wide timing plates that can make contact with the sensors, and then some controller. Right, so we're gonna make a solid crank, which is the regular stroke, which looks like this. So it's not a variable stroke, but I'll show you later how to make one. So yeah, let's connect this to the controller, and let's place a bearing here, and then pipe facing up, and we're gonna make an 8 piston. There's also a version where you can make 4 pistons, so which is pretty cool. Actually, you can just place a wheel here. Oh shoot. Alright, so let's place wheel. Alright, so yeah, and some pipes facing that way, and then we can use the corner pipe and then weld them together. Some pistons again, pipe facing that way, and then another one of those corner pipes, and then some pipes like this and like that. And the last parts, we're gonna make it do the same way like the other one, like the other side here. Some pistons, and then as usual we're gonna connect them into this thing, to the body pretty much. Alright, so we're done making the engine itself. Let's not forget about the color mode. And for the piston value, it's going to be some of them are going to be 2 and some of them are going to be 3. But here it's going to be 2. Actually, no, this is 3. 3 fastest. Wait, no, I'm wrong. And this is supposed to be 2. So 2, and then this is going to be 3. And then this is going to be 2. And this is going to be 3. Alright. So now let's time. Let's set up our timing. Just make sure to follow these timing very closely. So like this. Now let's weld it to the ground and test it. Just put an accelerometer, and then let's paint the timing plates. Alright. So now it starts spinning. It's pretty nice. So let's put a switch. Of course, you're not gonna need to use some logic gates since you're just going to waste performance with that. Actually, what the hell is this engine stead zone? Oh, there it is. So 180. Let's try 180. Let's check. It's doing 500 at the moment. Maybe if we advance the timing. And nearly 600, maybe a little bit even more. And that's about slightly more than 600. Okay, that's pretty crazy. And yeah, that's about 600 RPM. Maybe let's retard the timing a little bit. Alright, yeah, that's 600 RPM, 8 piston engine. You can make it have on both sides. Don't forget to pass through here though, otherwise this will be wobbling pretty crazy. So yeah, this is the 8 piston variation. Now I'll teach you how to make a variable short stroke. Alright, so now let's get started to make the variable stroke kind engine. So of course, as usual, you're gonna make a pass through, and then some couple of the sensors, of course, 90-degree offset. take that off, and let's put some the timing plate as usual. Of course, it's going to be 4, and then a controller and a bearing for our timing. Don't forget to balance the crank. Under here, we're gonna put a bearing, a pipe facing up here, and then a corner pipe like this, another pipe here, and then a screw. And here, another pipe. Yeah. So let's put a piston here now. Finally, okay. A friend has just joined. Nice. So let's put a couple of pistons here, as usual. Alright, so now let's put this piston and put a pipe, another pipe like this, and like this. And then let's put another piston like this, like that, and weld it to the bottom. Very nice. Now, don't forget to set the piston range to like 2 once again, and don't forget to connect the bearing. Now let's set our timing. The timing is going to be the same thing as the other one. So now let's add some color mode for our sensors. Now we can now place the wheel. The wheel serves as our flywheel, or the wheel pretty much. Now let's put a switch. Now number 2 is our stroke. So if you guys want 700 RPM, I recommend going 40 to 50, and that's going to be minimal for 700 RPM. But if you guys want 1000 RPM, then you go 25, either 25 or lower, or higher 25. But 25 is going to be the ideal for me. So yeah, so let's now paint this, and pretty sure the let's make sure that this thing is in dead zone, completely in dead zone. So it's negative 120, like that. Let's advance the timing to like 225, and let's add accelerometer. So let's measure the RPM once again. It's weird though, so let's try to adjust this thing once again. Alright, so now maybe if we advance the timing a little bit more, and more. Alright, so 1200 RPM. So this is the variable stroke piston engine for the, or a variable stroke kind engine. Thing is, this doesn't have any torque. So, well, yes, you may be right, but there is a car that I made that has that type of engine. Okay, so as you guys can see, the video quality is slightly lowered, and we are in a different world. Well, this is because I need more FPS, because apparently low FPS will just cause the engines to jam, or mostly kind engines. And I've only got one mods loaded in, which is the accelerometer, and yeah. So I called the car All Now Mark II, and the Mark 1 is pretty much just a 700 RPM missile, but this is a 200 kilometers per hour missile. So yeah, let's load this thing up. This thing can do 1200 RPM on the wheels, just like the other car I made usually. And yeah, let's test this thing out. So oh, there's already a freaking accelerometer. I might want to remove that because it's on my workshop. And if you guys want to try this out, it's on my workshop. So yeah, let's go. Now I'm gonna try to explain things properly here. So as you guys can see, the engine looks like this. This is because of the accelerometer I put. The reason of this accelerometer is pretty much size and reduced inertia according to Kind, which is of course more efficiency. And instead of the sensors spinning, we have the blocks. So if I go here and if I press W, the blocks spin here instead. Oh, the engine just started reversing. I don't know why, but yeah, that's the engine pretty much. And instead of pipes, I use blocks for the variable stroke. And this is probably mostly because of the balancing, because apparently according to Kind this is better, so I used blocks. And about this thing here with the floating bearing here, this is mostly because of the steering and to reduce the size, and yeah, that's pretty much it. That's 0th block technology right there. So yeah, now let's just start to drive this thing. Okay, so we have 3 different speedometers here. Green means slow cruising speed. We have blue, which is faster cruising speed, and then red is pretty much top speed mode. So yeah, now let's start driving. It just usually does this for some reason. I really don't know why. Sometimes the car just doesn't steer at all, mostly because of the terrible suspension setup, or the probably terrible suspension glitch setup, which is, yeah. The reason of the suspension glitch, by the way, is to counteract the engine torque. So alright, let's go for the high speed mode. It can do 130 kilometers per hour on the higher speed mode. It's all-wheel drive, so the controls are okay-ish. But top speed mode, you should just keep the car stabilized. And I mean stabilized. This thing is a 200 kilometers per hour missile. Well, only if you have good FPS. And I'm lagging right now, and the suspension glitch just kind of like malfunctioned right there, and causes the car's front end to like shift, you know. So I mean, yeah, this is what I'm talking about. So which means the rear tends to get free and less grip. So I guess we have like less top speed here. So yeah, just as much as possible you must prevent lag in order to hit 200 kilometers with this thing. Alright, so yeah, that's pretty much the car. I also made a second cooler car, which you may or may not like, which is the piston powered Honda NSX. Alright, this one is like slower than the other one, but this one is still fast. I can consider it fast because it uses the same engine. Well, but this engine specifically is only 700 RPM. But this car is actually much heavier than the other car. The other car was just like only 1.1 tons. Wait, no, it's not 1.1 tons. Maybe like even less, but I'll check it out later. But this is the Honda NSX. 8 pistons, which is like short 8 pistons than the other one. And as you guys can see, I put pistons here in order to you know, avoid collisions with the pistons itself, because the travel of these pistons is a little bit big for this type of engine bay. So I ended up coming up with this type of engine bay design. Suspension wise, it's pretty much the same. It's variable, but of course, if I made the suspension a little more complex, my game will lag. And yeah, and this one also has the suspension glitch, but normally it doesn't need them, but I needed them for mostly handling. There's also an option to disable the suspension glitch for this thing, so let's show the car right now. And there's only 2 cruising speeds, with white being slow cruising speed, or maybe if you're lucky, maybe you can get it to reverse. But anyways, let's just activate the car right now. So yeah, this is the cruising speed. The cruising speed is like slightly faster than the other one. This thing can go like 90 kilometers per hour or 90 kilometers per hour max. Alright, so let's go to the top speed, with blue being the top speed. The top speed for without the DRS I made, which is the suspension glitch, which is like only 140 kilometers an hour. But if I enable the DRS mode, which kind of like disables the suspension glitch counteracting the torque of the piston engine, this thing can go 150 kilometers an hour, which is pretty great. I guess. Unfortunately, I can't really get it to 160 because 160 kilometers per hour requires more power, and I have done so much tuning in this car, to the point where it's like, you know, capable of lifting this 1.1 ton car. Yeah, because this is a 1.81 ton car. To be specific, it's 1.18 pound. I mean 1.18 ton car, which is 1.2 tons, which is, I can consider that pretty heavy for these 8 pistons. But yeah, this is the car itself. It's pretty great. I forgot to mention about the front suspension setup. A double wishbone suspension, which are pretty damn soft, so we can make the rear end loose a little bit for more handling. But sadly, this will just get me more oversteer. But for some reason, this car rarely oversteers, and I am telling you that this doesn't like oversteer. It's just drift turns, which is pretty cool. Like, yes. And if I enable the top speed mode, just yeah, it's understeer all the way. So yeah, this is the entire car pretty much. It's probably like the most reliable out here. Because engine doesn't reverse sometimes, but it can reverse. But yeah, it's a pretty good one. I can probably like tune this car a little bit more so it can go 160 kilometers per hour, because apparently Kind said this is possible for 160 kilometers per hour. So yeah, if you guys want to try out these cars, I recommend just checking them out and pretty much see how they work and how they were built and stuff. So yeah, thank you guys so much for watching, and I'll see you on my next video. Goodbye.